Alright, good afternoon, student. Welcome back to Mr. Chen's Masterclass. Welcome back to my YouTube channel for pre-cal. Okay, so today we would like to talk about that section 9.4. So this one is showing that 7.4 matrices and system of equation. So this one is the same as the sections from the James Stewart pre-cal. So section 9.4. So we'll talk about some of the main topic such as the row echelon form, reduced echelon form, and also we'll get into the elementary row operation to find out the simplest form for the amended matrices. Okay, so anytime they see like A1, A2, A3, or A11, so that means the number of entry in the first row, first column, first row, second column, first row, the third column, so on and so forth. So the matrices, you can set up any kind of number of rows and columns. So n, that represents the number of rows, and n, that represents the number of columns. So for the row echelon form, so we need to satisfy the following condition. So in order to have a row echelon form. So echelon, that's just like one of the, like a mathematic operations for doing the matrices. And also is one of the mathematician's name. So the first condition is showing that any rows consisting entirely of 0 occur at the bottom of the matrix. So anytime they see like the bottom row, it's all zeros. So that would be considered the row echelon form. And then number 2, for each row that does not consist entirely of 0, and the first non-zero entry, it's 1. So this one basically, it shows that this special feature of the row echelon form. And then condition number 3, so for 2 successive non-zero rows, so the leading 1 in the higher row, it's farther to the left than the leading 1 in the lower row. Okay, so we're going to find out. So like this type of example right here, so for A, so as you can see that, so this one, the leading 1, this one is actually, it's on the right compared to the bottom row. So this one is not the row echelon form. But this one, yes, because that the 1, it's on the left, on the most left, on the first row, and then the bottom one, it's on the most right, on the second row. And also this one, it's not the row echelon form because the 0, so the 0 row is supposed to be down the bottom, but somehow this one is right in between. And then the third one, it is the row echelon form. See all the 1 here? It shows that the diagonal. So the row, the leading 1, it's always on the left. Okay? And then the bottom row, it's all 0. So now, and what about the reduced echelon form, the reduced row echelon form? So a matrix in row echelon form, it's in reduced row echelon form. If every column that has a leading 1 and has zeros in every position above and below its leading 1. So as you can see that right here, the 1, it's right above, down below, the 1 down below with all the 0, right above with all the 0. Well, this one it's not because the 0 is supposed to be down the bottom, but this one, yes. So for B and D, this one's supposed to be the reduced row echelon form. So besides being the row echelon form, but they're also considered the reduced row echelon. So for A, it's not considered the row echelon. And then for C, I mean, this one technically, you guys, well, just finished out the other part, elementary row operation. If we try to swap the second row, the third row, it's also considered the row echelon. But this one doesn't mention anything switching. So if this one is given like this one is not either one of those. It's not the row echelon, or it's not even the reduced row echelon form. So now, what about the way to find out the solving the system with the amended matrix by using the elementary row operation or using the reduced row echelon process? So here's the step that I can follow through. So you can either add a multiples of one row to another, step 2, or any step, you can just follow through that randomly. Multiply a row by non-zero constant, interchange 2 rows. Okay? So we're going to do some example like this. So let's start it off with 2a. So again, that's the one that I mentioned above right here. So A, it's not the row echelon form, so it cannot be the reduced echelon. But for B, it could be both. It's a row echelon. It's also the reduced echelon form. And then for E, this one, it's not the row echelon because the 0 row is supposed to be down the bottom. But for D, this one, it's a row echelon. But it's not the reduced row echelon. Because right above the 1, this one's supposed to be 0, 0. Above the 1 here, this one's supposed to be 0. Instead of being 2, this one, instead of being negative 1, 6, should be 0, 0. So this one is only the row echelon. Okay, so now let's use the elementary row operation to find out the following matrices for the solutions of xy, xyz. So again, if you find out anything that need to parameterize, so we need to do that as well. Okay, so started with A. Okay, so let me put it right here. So the way to follow through by using the row echelon form or the reduced row echelon form. So first thing that you want to do, you want to convert the linear system to the amended matrix. So this one is considered 2 by 3. So we do have 2, 1, 5 for the first row. And then second row, we do have negative 1, 3, and 7. So the number that I pull out here, those are just the coefficient. So 2, 1, 5, negative 1, 3, 7. And then this one here, according to that, the row echelon form. So we need to start it with the first entry. So the first entry, first row, first column, we need to convert that number to 1. So the easy way to do it, so just multiply the first row by 1/2. And then replace that for row 1. So multiply the first row by 1/2, so we got 1/2 times 2, which is 1. 1/2 times 1, 1/2. And then 1/2 times 5, 5/2. We can certainly do that. But the thing is that some people don't want to deal with fraction. So what's the other way to do it? So the other way to do it, we just follow through one of the operation. We can always combine the rows together. So instead of multiplying the first row by 1/2, we can combine row 1 and row 2 together. And then the result, just place that in row 1. So 2 plus negative 1, that's 1. 1 plus 3, that's 4. 5 plus 7, then that'll be 12. And then second row, just carry those number all the way through. So that's step 1. So step 2. So the next one, we need to think about it. Negative 1, we need to convert that to 0. So the easy way to do it, combine row 1, row 2 from what we found. And then replace that for row 2. Okay, row 1, row 2. So put it back to row 2. Okay, so 1 plus negative 1, 0. 4 plus 3, 7. 12 plus 7, 19. Everything else on the top, just carry them over. And now, here's the next step that you want to think about. So we need to change this entry to 1. Again, we need to get the leading coefficient to 1. So for 7, in order to get that to 1, so the easy way to do it, okay, so if that's possible, so we can multiply the first row by 2 and then subtract if that's possible. But if you try to do that, we'll change that 0 to a non-zero constant, so you don't want to do that. So the easy way to do it, multiply row 2 by 1 over 7 and put it back to row 2. Okay, so 1, 4, 12, first row, just keep those number. So 0 times 1, 7, 0. 1, 7 times 7, that's 1. And then 1 over 7 times 19, 19 over 7. So here's what we found. And now the last thing that you want to do for step 3. So pretty much right now we're getting down to the row echelon form. But once you want to find out the simplest, the reduced row echelon form, so we want to simplify it a little bit more. Step 4. Okay, so that was step 3. Step 4. So now for that 4 right there, we need to convert that to 0 by using the elementary row operation. So what we can do here, so this one, let's multiply the second row by -4. And then add it with row 1. So second row times -4, 0 times -4, 0 plus 1. Let's do 1. 1 times 4, 1 times -4, -4 plus 4, 0. 19 over 7 times -4, then that would be considered negative. Okay, so let's see right here. 7 times, well, it's over -7, so 19 times 4, 9 times 4, 36, 1 times 4, 4, so plus 3, -76 over 7. Okay, and then plus 12. Okay, so keep it that way. And then what else do we have? So 0, 1, 19 over 7. So basically this one, the one that you find out here, and guess what that is? The value of x and y. So for 1x, what is that equal to? It's negative 1776 over 7 plus 12. So 7 times 12, 84. Negative 76 plus 84. Then that'd be a over 7. And then for y, which is 19 over 7. Okay, like that. And you can always check the work by plugging a number back to the original equation. So a over 7 times 2, 16 over 7. Y, 19 over 7. Combine them. What is that? 35 over 7, which is 5. And then plugging that to the second equation, you'll see that negative a over 7 plus 3 times 19 over 7. So 3 times 19, 54. 54 minus 8, which is, let's see, 49. Okay, so this one here, so 49 over 7, which is what? 7. 3 times 19 is actually 57, so 57 minus 8. So it's 49. 49 over 7. 7 over... So that would be 7. So it's all fractions. So again, the row echelon operation. Okay, so now let's do another problem like this. Okay, let's do the one with the 3 by 4. The size of 3 by 4 matrix. Okay, so like B right here. Okay, so let's put it out. So this time I'll be writing, it's a little bit smaller because it's going to be a lot of work for this one. Okay, so again, give the name. So row 1, row 2, row 3. So first thing that I want to do, convert that to the amended matrix. So we got negative 1, 1, 1, 3, first row. And then second row, 1, negative 1, 1, 4. Third row, 1, 1, negative 1, 5. Okay, so again, first thing that I want to do, convert the first leading entry to 1. So just simply multiply everything by negative 1. So row 1 times negative 1. Replace that for row 1. So negative 1 times 1, positive, negative, negative, negative 3. Everything else, just rewrite it. 1, negative 1, 1, 4. 1, 1, negative 1, 5. Next thing that you want to do, convert that, the second row, the first entry, to 0. So what you can do here, so combine that or subtract row 2 and row 1 and then put into row 2. So 1 minus 1, 0. Negative 1 minus negative 1, 0. and then 1 minus negative 1, 2, 4 minus negative 3, 7. First row, all those entries, the numbers, just carry them over. 1, 1, negative 1, 5, carry them over. Okay, so the next thing that we can do, step 3. So this entry here, we want to convert that to 0. So this one, the easy way to do it, subtract row 3 and row 1, place that in row 3. Okay. So 1 minus 1, 0. 1 minus negative 1, 2. Negative 1 minus negative 1, 0. 5 minus negative 3, 8. So everything else, just carry them over. Okay, so now the next number, the one that we need to convert that to, it's the 1. Again, all the leading 1 got to be right here in the diagonal. So this number here, we want to convert that to 1. So the way to do it, so it's row 2. Let's see, because this one is already in 0 form. So one thing that we can do, we can swap the row. Okay, so we can switch the row, exchange 2 rows. So instead of converting this 1 to 1, so switch that row 2 in row 3, and then place that in row 2. So what we found out here, it's 1, negative 1, negative 1, negative 3. So switch that row to row 3. So 0, 2, 0, 8. So this bottom row here, 0, 0, 2, 7. So the better way to do it is because that we're almost getting close to 1 for the main diagonal. So the next number for the 2, convert that to 1. So the way to do it, so you want to combine, let's see, instead of combining it, just multiply row 2 by 1/2. Place that in row 2. Because once you add row 1, row 2, we can convert that to 1. But somehow, the 0, the one that we changed, this one will be going back to the non-zero constant. So which is, you try to avoid. You don't want to do that. So first row, bring down those number. So second row, multiply by 1/2. So we got 0. 1/2 times 0, which is 0. 1/2 times 2, 1. 0 times 1/2, 0. 1/2 times 8, 4. Third row, those number, carry them over. And finally, okay, so this one's step 1, step 2, step 3, step 4, step 5, that's what we just did. Step 6. So now, the upper number right here, again, anything that above the leading 1, it should be 0 for the reduced row echelon. So in order to convert that to negative 1 to 0, so what we can do, so combine row 1 and row 2 together and place that in row 1. Okay, so 1 plus 0, that's 1. Negative 1 plus 1, 0. Negative 1 plus 0, negative 1. And then negative 3 plus 4, 1. Everything else, just rewrite it. So we're getting there. And then the next step, so for that 2, we want to convert that to 1. So in order to convert that to 1, again, you can multiply the row by the scalar. So row 3 times 1/2. Place that in row 3. So we got 0, 0, 1, 7 over 2. Everything else, just rewrite it. 1, 0, negative 1, 1, 0, 1, 0, 4. So we're almost getting there. And then the last piece right here, we just want to get that negative 1 to 0. So in order to do that, excuse me, so combine that row 1 and row 3 together. So row 1 plus row 3. Combine them and then put into row 1. Okay, so 1 plus 0, that's 1. 0 plus 0, 0. Negative 1 plus 1, 0. 1 plus 7/2, 2 over 2 plus 7/2, which is 9 over 2. And then finally, we're getting to the reduced row echelon form. So what this one is showing here, x equals 9 half, y equals 4, and then z equals 7 half. Okay, so check this. Negative 9 over 2 plus 4, a over 4, well, 4a over 2, then that'd be 1 half. 1 half plus 7 over 2. Wait a minute. So negative 9 over 2 plus y, so a over 2, and then plus 7 over 2, yeah. So this one is what, 6 over 2, which is what, 3. Check the first equation. Now, for those of you who might be wondering, how do we check this on the TI, the graphing calculator? So here's what we can do. So put in the amended matrix, so this one is what, 3 by 4, and then you want to calculate the reduced row echelon. Okay, so here's what I'm going to show you. So let me just put it this one side by side, if that's possible. So let me just put this one on the left. Then the calculator. Oops. We need a calculator right here, the TI, excuse me. Okay, so put this one on the left. Okay, so showing that the amended matrix. So what we got here. Okay, so you want to go to matrix. Whoops. So second matrix. Okay, so add it. So this one is a 3 by 4. Okay, so 3 by 4. Okay, so put in those entry. So for the entry that we got here, so we got negative 1, 1, negative 1, 1, 1, 3. So we got negative 1, 1, 1, and 3. Okay, making sure that, okay, this one, enter. So that takes care of the first row. And then the second row that we got here is 1, negative 1, 1, 4. 1, negative 1, 1, and 4. Making sure that this one is all correct. Enter. And then the third row. So the third row we have is 1, 1, negative 1, 5. Okay, so 1, 1, negative 1, and 5. So make sure that you guys double checking the entry. You're not getting the wrong number there. Okay, so here's what we got. So we enter into matrix A, 3 by 4. So now, once you're done with this, guess what you can do? Okay, so this one, go back to the home page. And then go back to second matrix. And then you want to go to edit. No, not edit. You want to go to math. And then press the down cursor. You'll see that R, R, E, F. So we do have two of those. One is the row echelon, reduced echelon form. But the things that the one we want is the reduced row echelon form. Okay, not just the reduced echelon form. That's not the simplest form. It's the reduced row echelon form. That's the one we want. Okay, so press that, enter. And then second, matrix once again. So the one that you just stored right there, matrix A, press 1. Close parentheses, and then press enter. So here's what we found. So the value of x, the value of y, and the value of z. So 4.5, 3, 3.5. So check out the one that we got here. Okay, so 4.5, 4, and then 3.5. Okay, so pretty cool, right? Okay, so now go back and the rest of this. So pretty much you want to do the same thing. Row echelon, reduce row echelon. So if you find out things that cannot be done by the reduced row echelon, so just, find out that the simplest form. And then from there, you want to come up with the, just parameterize the variable. If you find out things that cannot be solving all the way through, okay, so just enter those number on the calculator, and then you find out that z equals something, and then y, it's going to be like in terms of x or something. So you need to parameterize the variable. Okay, so what about for this one, the traffic flow through the network of street is shown below. Write the system equation that models the traffic flow in vehicle per hour. Do not solve the system. So as you can see that we do have A, B, C, D, E, F. So let's see, 1, 2, 3, 4, 5, 6 variable. So that means we need to set up the linear system equation, 6 linear equations. So it's going to be this one is going to be considered a 7, well let's see. So it's going to be a 6 by 7 amended matrix. So the way to set it up, so start it off with the first one. So 400 plus A plus E. So that equals, what's the outcome here? So it's going to be 250. So that's the first equation. So the second equation, then that will be considered 400 minus B, because that's going down. And then minus, well, this one keep going to the right, plus D. And then the outcome is going to be what? 300. And then the third one, okay, so started with 400 again. Also minus B, but goes back up, plus C. And then plus E. And then the outcome, 250. Again, we need 6 equations, okay? So the fourth equation, and this time, so started off with the bottom one, 150 plus D. So this one is actually the straightforward one, all the way through, all straight. So this one is 300. And then the fifth one, 150. Okay, so this one going back, going to this knob here and go to C, plus C, and then plus E. So that equals 250. And then finally, the last one, 150. Oh, this one is going back down. So we cannot use 150. 150, we use that already. So this one's going back down. Okay, let me just... So the last one, then that'll be 400. Okay, so going to this now, plus A, plus E. And then goes back down, minus F. Going down, right? And then, so that equals what? All the way to 300. Okay, so 6 equations, so 6 variables, A, B, C, D, E, and F. Okay, so 6 equations. So you want to convert that, each equations, to its amended matrix row. So, but you need to line up the ladder first, alphabetically. Okay, from A all the way to F. So once you line up the equations, the linear system equations, so you convert that to amended matrix. Okay, so again, no need to solve for the system. Okay, so that's it. So a lot of information going on here. So make sure that you understand that the difference of the row echelon and the reduced echelon form. Okay, so that makes a difference. Like this one right here. Okay. And also the operations to put in that the reduced row echelon form. So we can so that would be able to solve for x, y, z for the rest of the equation. So add the multiples of one row to another, multiples of row, multiply a row by non-zero constant, multiply, not multiple, and then interchange 2 rows. Okay, so those are the strategy. We can come up with the reduced row echelon form. Okay, so that's it. Thank you for watching the video today. So I'll see you guys next time. And don't forget to subscribe to the channel. Okay, so I'll see you guys next time. Take care.